All right, welcome back, friends. It is geometry. We're going to do 1.3 part 1 notes today, so that means we're all about midpoint. So looking on the screen here, and I'm looking down on my iPad, you can see that we are going to use vocabulary based on the undefined terms to develop the foundations of geometry. It's the same one, so we're still building from our initial essential vocabulary from the first day, and we're building up. So we've taken those undefined terms, point, line, plane, and we've kind of built, we talked about segment, addition, postulate. Today we're going to go more to midpoint, so still dealing with distance, maybe a little segment, addition, postulate showing up, and also going into the mid segment, or not mid segment, midpoint, excuse me. So looking here, I went ahead and had the definition prepared for you guys for midpoint. It's the point that divides the segment into two congruent segments. Now, before I break that down, I just want to say it is very straightforward. The midpoint is the middle point. Also, we can have a midpoint of a segment. Notice that it says segment. We are never going to have the midpoint of a line, because it goes on forever in both directions, so we're not able to exactly say where the middle of a line is because it's going on forever. For the same reason, we cannot find the midpoint of a ray. So when we're talking about midpoints, we're talking about line segments, a finite distance between 2 points, and we can find the exact middle of that. Also, going to bring up this here, two congruent segments, which we learned last time. Congruent meant they were the same. We also know that they are segments that will have equal distances, but for congruent, we think they are the same. They're copies of each other. They will map on top of each other. So different than equality, but very one-to-one type of relationship. I want to bring you also over here to these pictures just to take a look at. Notice those red tick marks. Those red tick marks are going to be something I'm going to talk about here in just 1 second. What they show is congruency. But before that, let's talk about our set one, segment bisector. Segment bisector, and I underlined the bisector part. The bisector simply means, and actually before I talk about what that means, I want to talk about what a segment bisector is, and we'll see if we can figure it out. A segment bisector is a point, ray, line segment, or plane that intersects a segment at its midpoint. So a bisector is something that intersects something at its middle. A segment bisector then is something that intersects a segment at the middle. A bisector, I want you to think, cuts something in half. It doesn't matter what that something is. In geometry, it could be a point, it could be a line, it could be a plane, it could be a line segment, it could be a ray. It doesn't matter as long as it's cutting the segment in half. It is a segment bisector. So if you take a look at all these pictures here, if you look at this one, here's the segment. It's being cut in half by the line. So that line L is the segment bisector. We look over here, here's CD, it's being cut in half by a line segment. So that green line segment, which is QP, is the bisector. Whatever is doing the cutting. If you go to Subway and you get a sandwich, at the end they cut that sandwich in half. That person, that worker, they are a sandwich bisector. It is whoever or whatever is doing the cutting. And you can see the examples over here as well. Now, some of you seeing, or I pointed out to you, those tick marks. So here, let me give another segment here. If I were to draw this segment, and we'll call it XY, and I'll put a midpoint in the middle. And this is important because I want to show it is in the middle. If I have an M in midpoint, right now I don't know that it's in the middle. I can say, oh, it looks like it, but that's not going to be good enough for us. So what we do in geometry, and what I want you guys to start to do with all the other geometry students around the world, is start using those little, I say tick marks, those little dashes to show when two segments are congruent. So if I want to show that M is in the middle, what I want to show is that, hey, XM is the same as MY, and that's a Y over here. If I do that, then I can say that this distance is the same as this distance, and so M is directly in the middle. So for congruency on our pictures, on our diagrams, we'll use tick marks to make sure that we are giving as much information to the audience as possible. So we go over a lot of things as far as communication. It's with our pictures, it's with our vocab, our notation, how we're speaking aloud. So that's a big part of this foundations or this essentials of geometry unit. Let's go to examples. So pretty intuitive. I do want to point out on this here, look at the tick marks. That shows us they are the same. So if they are the same, that means they also have equal distance. So if RT is 21.7, TS will also be 21.7. So find RS. RS is the entire segment. You maybe not want to do all this work, but it's important. RS by the segment addition postulate says if I take the parts, add them together, I get the whole. So RS is equal to RT plus TS. I know that because the segment addition postulate went over last unit. Then I'm going to substitute in the values. RS is equal to, well, RT is 21.7 and TS is 21.7. So then I can combine like terms, and RS is equal to 21.7 plus 21.7. We're getting 43.4. And right now, I'm not going to box in my answers because we're not done. And I want to point out one thing. We read this as the distance from R to S is equal to 43.4 units. Please do not forget your units. So yeah, using the idea of midpoint to find values. Example 2, point C is the midpoint of segment BD. Find the length of BC. So here's what we know about midpoint. Midpoint is the exact middle, and it creates two congruent segments. If two segments are congruent, and how I know that they are congruent is on my picture here. I got my tick marks. If I know that BC, the segment BC, is congruent to segment CD, if I know this, then the definition of congruent segments tells me that, hey, if they are congruent, they also have to be equal. So they are equal, and we know we have values for them. So for example, BC, over here I see it's 3x plus 2. In CD, they tell me it's 2x plus 3. And from here, it's algebra. I can solve this to find x. So I'm going to take away 2x from both sides, and at the same time, I'm going to take away 2 from both sides. So I have the 2x's canceling out, the 2's cancel out. I'm left with x equals 1. That is not our final answer. We always refer back to the original instructions. It says find the length of BC. So I'm going to go back to segment BC, and BC was given to me as 3x minus 2. I now have over here that x is equal to 1, so I will substitute in what I know. So BC is equal to 3 times 1 minus 2. So the distance from B to C, the length of segment BC, if you will, is equal to 1 unit. And that would be our final answer. So there's a little bit of midpoint. We did see segment addition postulate like I thought we would, and now we're going to specifically focus on midpoint in the coordinate plane. So the coordinates of the midpoint of a segment are the averages of the x coordinates and the y coordinates. So averages of the x coordinates and the y coordinates of the endpoints. So we're given two endpoints, and if I want to find the middle, I want to find the average of their coordinates. So if A is x1, y1, and B is x2, y2 on the coordinate plane, then the midpoint M of segment AB has the coordinates, and we got this nice old midpoint formula. But if you were to take a look at it, it simply just is averaging those two values, adding the values together and dividing by the number of values we have. So adding the two numbers together and dividing by 2. And that's what's kind of shown right here. We can see that for the y1 and y2 value to find the middle, well, you add them together and divide by 2. And the same with x1 and x2, you add them together and you divide by 2. And that's how we're getting these formulas. And it kind of is a good graphic representation. So we're going to take this formula, we're going to take these ideas, and we're going to do a couple more examples with midpoint. So find midpoint. It says the endpoints of segment PR are P negative 2, 5, and R is 4, 3. Find the coordinates of midpoint M. So I'm going to use the midpoint formula. I'm kind of tired of green though. Let's go to red. So my midpoint formula says x1 plus x2 over 2 and y1 plus y2 over 2. And something that I like to do that I recommend that you try, especially with a formula that is not as difficult to use that we will as ones that you've seen in the past and ones we've seen in the future. This is just adding two values together and dividing by 2. The number one place I see students make mistakes is just putting the values in the correct spot. So here is a little tip from me that I would recommend. Here is my first point P. There's my x and y coordinate. So I'm going to say x1, y1. My first x, my first y. For r, that's x2 and y2. My second x, my second y. Then I'm going to go ahead and put this in my formula. I'm just kind of setting up areas. So instead of me using x1, y1, x2, y2, I'm going to use the actual values that they gave us. So x1 is negative 2, and I can see that x2 is 4. I can see that y1 from my label is 5, and I can see that y2 is 3. So we're going to simplify this to get our point. So right now, negative 2 plus 4, that's 2 over 2, comma 5 plus 3 is 8 over 2, and it looks like I'll have to go one more. And then we check to see if we can divide, and we can. We can simplify. 2 divided by 2 is 1. 8 divided by 2 is 4. The only thing that I'm missing here, those are the correct coordinates. It is the final answer. However, I want to direct you back. Notation, notation, notation. It is point M. So I want to label it point M, our midpoint, and that will be our final answer. All right, so there we go. And I believe, yep, this is the last example, and then we are done with the video notes for this. This says, and it's a little bit different, let me highlight, find the endpoint. So there's going to be a couple ways that we can kind of attack it, but let's just see what they give us. The midpoint of AC is the point M34. One endpoint is A16. Find the coordinates of endpoint C. So first I'm just going to kind of sketch a picture for you guys to see kind of what we got going on here. We are given a segment, and this is not going to be perfectly to scale with the coordinate plane. I'm just trying to give you a sketch so you can visualize. They say that of this segment AC, they found the midpoint M. We are given M is 3, 4, and we're given A is 1, 6. And as you can see, that is not true as to if this were on the coordinate plane. I just want to show you what we are looking for here is the coordinates of point C, and that's a terrible question mark. We are looking for the coordinates of point C. So how are we going to do this? We are still going to use our midpoint formula. I'm going to move over here. Midpoint formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. And kind of what we're given here is we're given one x and y value. We're given x1, y1, but we're not given x2, y2. And if you're thinking this over here, like, whoa, isn't that supposed to be x2, y2, or is that supposed to be x1, y1? That's our final answer from our last question. We're going backwards. So this will give us, this midpoint will give us 3, 4. The formula will get that. So what we're looking for is the missing information. So let's plug in to see what we got and see what we don't. So just plug in here, x1 is 1, plus we do not have an x2 over 2, divided by y1, we have a 6, plus y2 over 2. And again, those will equal 3 and 4, but we don't have x1 and x2. That's actually going to be our final answer. So I'm going to switch colors and I'm going to kind of group things here. This is 1 plus x2, or 1 plus x2 over 2. That should equal 3. And this, actually maybe not purple. 6 plus y2 over 2, that should equal 4. So we're going to set up two separate equations here. If we're able to isolate those and solve, we should be able to get the coordinates of C. So for green, 1 plus x2 over 2 equals 3. I would multiply by 2 on both sides. 1 plus x2 equals 6. Take away 1 from both sides, and we have x2 equals 6. And for black, we're going to do the same thing. We have 6 plus y2 over 2 equals 4. Multiply by 2 on both sides. 6 plus y2 equals 8. Take away 6 from both sides, and we get y2 equals 8. So these right here are kind of our final answers. I'm saying kind of because they give us the components, but we need to put it all together for our coordinates of C here. So C has the coordinates of 6, 8, and that will be it. So that is the conclusion of our 1.3 day 1 notes. It talks about midpoint, a little bit about segment addition postulate. We'll come together, we'll speak again next time that we're all in a group setting. I'll have some questions for you. I'm sure you'll have questions for me, but thank you so much again for watching, and we will see you next time.